Hello, good morning. Thank you for joining this webinar. And here and introduce myself. My name is Matthieu Guillon. I will speak for Oerlikon Balzers today. I'm in particular taking care of our diamond coating product management. In the background, I have a team also that have helped to this preparation and that will gather eventual comments or questions during the webinar. So it's Pierre who is in charge of supporting Europe from a technical standpoint. And we have also Stephanie with us, who is the manager of our Diamond Center in Luxembourg. The agenda we have prepared relatively, I think, meaningful. So we'd like to discuss the basics of what it is when we speak about a diamond. There are a couple of different technologies now in the industry. Then in the second part, we will explain, especially when it comes to diamond coatings, how it is made in the manufacturing, and lastly, we will show you some precise example in the Oerlikon Balzers world, how we do it and our equipment, for example. So let's start with some definition and an explanation what it is when we speak about diamond. That's comes a little bit through my experience talking on the market, that sometimes some technologies can be a little bit mixed up. So I'd like to explain this here. So here some key families to start with. Typically, on the far left, we speak about PCD. That's a famous one that people talked about. It's polycrystalline diamond. Here in that case, some crystals of diamond are assembled in a matrix, typically softer in its own features. So it's a mix of diamond and something else. Another technology of diamond is a so-called monocrystalline diamond. In that case, that's one piece of diamond that is grown in one single structure. And the other one is here a CVD diamond. That's an assembly of diamond crystals, and that's what we do typically on the coating side. So here with some interruptions, we add the diamond crystals one to the other to create a full 100% diamond structure. A little example of these technologies, how it looks like in real. So you see PCD, it's typically pressed and created in the form of a disc, of a wafer that is then cut into little parts and put, for example, on cutting tools. So that's the PCD tips. While the monocrystalline diamond, they will be used as their own piece and electroplated or galvanized or in some way glued to the support object, as you see on this example. And the difference with the CVD diamond coating is, since it's a coating and it's grown along the shape of the substrate of the object, you see it follows all complex shape that is provided, and all the dark gray structure is a grown diamond coatings over the tool. So you see here, so first three categories of that people may speak about when we speak about diamond. So there is a difference here. And another one I'd like to mention here, when we speak about coatings, there is another family that is called DLC. And you see the name here as well says diamond-like coating. It belongs indeed in the same family, a family that is called of carbon coatings, like the CVD diamond. So all these coatings and material are based out of carbon atoms. Now the difference between these DLC coatings versus diamond is the structure that is built out of these carbon atoms. I will explain a little bit later on, but if you see on the x-axis here we differentiate so-called sp2 atom structure to sp3, three-dimensional diamond structure. And the DLC coating, they have, I would say, only a mix of such structure, especially partially of the sp3 structure. So the DLC coating are a little bit harder than, I would say, traditional PVD coatings, but they do not reach the very high hardness of pure sp3 structure, which is CVD diamond. So you see, when you hear about diamond, the question is first, okay, between PCD, monocrystalline, DLC, CVD, what is diamond? What is the one we are talking about? And today we will move forward specifically with the CVD diamond coating specifically. In terms of industrial application, why do we talk about diamond? Sorry, it's typically first a large range of application or cutting tools for the machining of materials that are very abrasive. So you need a higher level protections for these cutting tools. Three big families are here. Graphite machining, where graphite electrodes for molds and electronics, but also graphite parts for electronic vehicles, batteries, needs to be machined. So it's very abrasive, and the cutting tools will benefit from very strong coating. Next type of family are modern fibers, reinforced materials, so carbon fiber, reinforced plastic, or glass fiber, or even specific plastics like PEEK are very abrasive. So typically also in terms of quality have a big advantage of being machined with a tool that is protected by a diamond coating. And here, last but not least, a very increasing application is also the tooth or teeth prostheses that are made out of zirconia ceramics, which is the mix of zirconium metal with silicium. It's a very up and coming ceramic because it can be tuned to the right color, but it's also very abrasive. So here, cutting tools to machine these prostheses will be protected by a diamond coating typically. Beside cutting tools, we also have applications of diamond coatings on components. For example, here briefly, dies for electrical wires use diamond coatings. We have also cases where, especially for water treatment, the electrodes will be coated with diamond coating. It's very corrosion resistant, and also chemically it's very neutral, so eliminate the need for additional chemicals. And here last, in the electronic industry, something a little bit new as well is the use of CVD diamond coating for such pads, as you see here, that are used along the CMP process. That is for the planarization of semiconductors and chips. So you see the usage of diamond coating can be very broad. Dominantly, especially for us, it's typically around the cutting tools, and that's where we focus a little bit more today. So here a little video. I hope it comes well through the presentation here for you online. Here a case of machining. Here that's an example of the zirconia machining, or here CNC milling with a cutting tool and a diamond coating, where this material is being machined, and each single tooth prosthesis here is custom made for an individual. So it's quite an intensive work, and diamond technology is here very, very important as well. And for this introduction, I think here I mentioned before quality and performance. What it is really, the difference is really about the tool life, how long the tool will be able to be used in these materials, and compared to an uncoated carbide tools, or I would say whatever PVD coating would be used, the hardness that we described before of CVD diamond always provide a significant improvement. So here it's very general, but that's what I've seen also personally along industry application, that you easily have a tool that will run 10 to 20 times longer through the hardness of a diamond coating versus an uncoated or PVD carbide tool. So now going ahead with the creation of this diamond coating, it is about, as I mentioned before, the carbon atoms and structure. Carbon is a fairly broadly spread atom in the world, so in all organic structure. And what we do during the coating process is an hybridization of this carbon atom. So we change the path of the electrons around the core, and then the atoms of carbons are able to connect differently. So I mentioned briefly before, you have so-called sp2 structures, which is a planar structure. For example, that's what graphite, as an example, is made of. For the diamond structure that we want to create using a chemical process of CVD, therefore CVD diamond, here we want to achieve a three-dimensional structure, which is called sp3. So in this configuration, or once we achieve this hybridization, the atoms of carbon will be able to connect one to the other in a three-dimensional cubic form, and that is the purest and strongest connection we can achieve with carbon atoms, creating the diamond structure. So this is what is going to happen fundamentally on the coating side. Industrially, in order to do so, we will also follow a relative complex path. So the example you see, or the graph you see in the middle, that's actually an extract of a real application. So you see it's quite a complex process with many steps. And the summary on the left, you see there is, of course, the cleaning and analysis when it comes to us. But the big step, and probably half of the work, despite speaking about coating, is the preparation before the coating. So we have a series of pre-treatment to prepare for this chemical reaction to happen at the surface of the substrate, and in our case, at the surface of the cutting tool. And I will explain this part here first. So in order to have the proper creation of the coating at the surface of the cutting tool, let's remember briefly what this cutting tool is made of. It's typically an assembly of tungsten and cobalt in the form of powder. Through mixing, pressing, and sintering, create your solid carbide object and substrate. And you see here already two different pictures showing it can be very different. So different by grain size, different by cobalt content. That's a higher criteria for the diamond coating, but also any other additional elements that might be added through the process. So the process I've shown before this slide is adapted to each, or needs to be adapted to each different carbide. So currently we consider on the Oerlikon Balzers side about 40 grades that we have qualified and analyzed, and for each of these grades we have adjusted the process to tailor the preparation of the carbide specifically and match the coating connection to it. And I'll show an example of this here, why it needs to be adjusted to the carbide. On the picture you see here, you see there are different colors, but the tool is not coated yet. It is only the pre-treatment that I mentioned before. So on the upper part, it's still the original rod of carbide ground from the grinding shop, and you see on the magnification, eventually we still see the grinding marks. And the bottom parts here for the validation process, we have done the pre-treatment. The color has changed, also a little bit the diameter already. And you see on the magnification, the structure has changed a lot. We basically removed to a certain depth and to a certain content, predominantly the cobalt. The effect of removing the cobalt here is to be able to insert some diamond powder, or I would say little babies to start, and also mechanically then to grow the diamond into this structure to ensure a mechanical binding between the diamond coating and the carbide. Therefore, very important, as I mentioned before, knowing the carbide and validating the carbide here is very important. If you try to do or grow a diamond coating or grow diamond or an unknown carbide, maybe this attachment is not provided correctly, and then the coating will flake very rapidly. So the qualification of carbide is very important as the coating. Assuming this is done properly, now we are ready to grow the diamond. If you remember the hybridization I mentioned before, so we will create this chemical reaction on the carbide, and the diamond structure will grow. And it takes in proportion a very long time. If you compare to your lawn in the garden or even to human hair, growing diamond as a structure is a very long process. For high quality diamond coating, the rate is typically around 0.2 micron per hour. So, and we can adjust it a little bit, but only maybe 0.25. So it's still a very long process to create this high quality layer. Therefore, if you consider the typical thickness that are used for the protection of the tool, so it goes from 4 micron to 15, in some rare cases 20 micron. Well, the tool can be in the coating process for up to 60 hours, so it's quite a long process. If you compare to PVD, it can be 3 to 4 hours maximum. So here CVD diamond is quite a long process as well, and also somewhat energy consuming. So this process during 60 hours is run at about 800 to 900 degrees C to ensure the chemical CVD reaction to happen and grow diamond. So you see, in terms of preparation and coating process, this requires some amount of time and work to create this properly. But here we go. After 60 hours or less, if we can work with 6 micron, for example, we have our diamond coating properly grown on the carbide substrate. The structure of the diamond can be adjusted. We will show some and see some example afterwards, where we see the diamond crystals at the surface. And here, very important, that's what we made the pre-treatment for, this layer of diamond is mechanically attached to the carbide at this layer phase. And now we have operated our coating. With the last part, so specifically now to our processes that at Oerlikon Balzers, and I mentioned the name before probably. So the family of CVD diamond is called BALDIA. Of course, in terms of this mechanical binding to the carbide, I mentioned it before, it's something we have specifically engineered and qualified around these 40 leading carbide to date, and we can extend, of course, if necessary. I also mentioned before, also the growth of the diamond crystal can be adjusted, and specifically to diamond, which is less usual on PVD, we adjust also particularly for each application or project the thickness that is really matching the requirement. Typically 6, 8, I would say 12 or widely used thickness, but there is not a predefined thickness like we would have for PVD coatings. So here the type of coating, but the thickness are always subject to the application and discussion. All these cases, as a global company, we have spread it quite evenly in the 3 big industrial regions worldwide. So this capability are in the US, in Michigan and California, well located centrally in Europe, in Germany and Luxembourg, and in Asia, in Korea, and recently we extended out of Suzhou in China. So out of these main locations, we are well positioned to serve all industrial locations. So we always here recommend to get in touch with our with our coating colleagues on the field, and always involve our coating specialists for diamond. So in Europe, we have 2 colleagues, Dirk and Pierre, available for you anytime to really discuss based on application and what is the purpose at the end user level, in order to choose along the options and characteristics that we have discussed before.